Hey guys, can you hear me? Um, I'm sorry, my throat is really bad. Pardon me. I'll be only talking for 15 minutes, so you won't have to bear too much with my stupid voice. But till that time, I appreciate your patience. Are you guys enjoying yourself at Ignite? Can you say that louder? Are you? Okay, that's good. So my name is Premal Shah. I'm a program manager at Microsoft and a good friend.
Am I on? Yeah, hey guys. So my name is Mike Cornell. I'm a senior solution architect with Databricks.
And just to make sure we are in the right place, this is managing your ML lifecycle with Azure Databricks and Azure Machine Learning. So we'll walk you through what are some of the problems and how we are helping solve, through this integration. So if you look at a typical ML lifecycle, you have data preparation that has to be done. So you have like a bunch of frameworks, bunch of tools that you have to use for data prep. So once you do that, once you gather data from a variety of sources, because you want like a bunch of data to build your model, the problem is that in traditional ML development is hard because in traditional software development, you're actually writing code, for a particular specification. So somebody tells you that, hey, when I click on that particular box, this validation should happen. If I click on this, this should happen. But in machine learning, the problems are a little different. Your goal is to optimize a metric. You want to get to the most accurate model possible. So you have to try like a bunch of models, a bunch of frameworks for you to be able to get there. Secondly is that the quality of your model depends upon your input parameters and your data. So the better your data, the more refined your data, the more feature engineered your data, the better the model that's going to come out. Also, you have to think about parameters, hyperparameters. And so again, there's an explosion of things that you need to do to arrive at the right model. Also, as all of us know in this room, there is like, myriad of software tools. So there is like no dearth of tools and frameworks out there. So as a data scientist, you have to make a lot of decisions about which tool to use, which framework to use to actually arrive at the right model. So that's another additional layer of complexity that comes into the picture. Now, this is the easy part. So once you have a model, the tough part is that how do you then productionalize it? So how do you deploy it into production? How do you manage your models? How do you deploy it to different surface areas? So how do you deploy it to the cloud? How do you deploy it to the edge? You might want to deploy it, in your database, for example. So how do you do sort of all those combinations? And then finally, once you have a model that's in production, how do you sort of monitor it? So how do you know that a model is continuing to be accurate? Because you'll have, data coming in, data is drifting, and how do you make sure that your model is accurate and is able to sort of meet the SLAs that you want your customers to meet? And finally, all of this is like a cycle, right? So you have to productionize your models, and depending upon what feedback you get, you have to retrain your models and so on. So as you can see, it's a pretty complicated process here. And on top of it all, as an enterprise, you want security, you want governance, and of course, you want scale. You want to do this at large scale, given the amount of data that you'll be dealing with. Before I go on, how many have heard of or sort of implemented Azure Databricks? Show of hands. Oh, awesome. So 50%. How about Azure Machine Learning? Any? Okay, that's good. So the next couple of slides, I'll just walk you through the basics of both these systems before we jump into sort of the integration part. So Azure Databricks is the premier Spark offering that we have on Azure. It's the fast collaborative platform. The nice thing about Azure Databricks is it's a unique first-party Azure offering, and we have partnered with Databricks, from where Mike is from. They're the world leaders in Spark. The founders of Spark founded Databricks. So this partnership is trying to bring the best of Azure and the best of Databricks and what we call Azure Databricks. And basically, we have three key philosophies in mind. One is that we as a team want to make sure that the productivity of the customer is at the maximum. So we want to make sure that you don't have to worry about the infrastructure issues that come with big data systems in terms of cluster creations, in terms of setting up permissions and all of that. So all of that complexity is taken away from you. Secondly is we have a very collaborative environment. So a bunch of data scientists can collaborate to build models. A bunch of data engineers can collaborate to get data in the right shape for you to be able to build models. So it's a very collaborative environment, and Mike will show you a demo, which some of it will come through that as well. The second thing is that we want to make sure that it's secure. So it's you have come to expect a certain level of security from Azure, and we want to make sure as part of the Azure Databricks team that we are maintaining that level of security that all of you have come to expect from Azure. And finally, a big data system has to scale. So you want to make sure that that it scales with you. So the nice thing about Azure Databricks is it has auto scaling. So you can start small and grow big, and you can grow small. So depending upon your workloads, the system scales. So it's essentially it's a very cost-effective way for you to scale as well. And being a first-party service, we've integrated with several other Azure services to offer you like a bunch of features and capabilities. So Azure Machine Learning is our end-to-end AI and machine learning platform in the cloud. There are many sessions on Azure Machine Learning at Ignite. Some of you might have actually been to them. But basically, similar to Azure Databricks, the first goal is to make data scientists productive. And by that, what I mean is that we really want to meet data scientists where they are. So whether you're in a Python, in PyCharm, or whether you are on a Jupyter notebook, you want to make sure that you can use Azure Machine Learning from wherever you are at, through its Python SDK. Secondly is that you saw the pain points in the slide where because of the number of models you have to generate to arrive at a successful model, you have to do a lot of experimentation. So you have to build different kinds of models and then be able to pick sort of one of them. And hence the rate of experimentation has to be really, really high. And you need a good system to support that, what Azure Machine Learning brings to the table. So things like hyperdrive integration helps you to increase your rate of experimentation for you to be able to build good models in a quickly and efficient and accurate manner. And finally, excuse me, once you build your model, you have to deploy the model in a variety of surface areas for your customers to be able to take advantage of that. So as you'll see, Azure Machine Learning is a very comprehensive model management capability in terms of data drifting. It can detect that data is drifting, and then you have a retraining loop and so on. So you can have an entire sort of end-to-end pipeline of machine learning. Sorry, I'm going to take a break, grab some water, and I'll start again. Thank you again for bearing with my voice. I really appreciate it. All right, so if you look at a typical machine learning sort of end-to-end process, and this is just one representation of the pipeline. So there could be sort of many representations, but typically, what we are accustomed to is that we prep data using a variety of data formats. We sort of train a model, and training has several connotations to it. So you build and train a model, you perform experimentation for you to arrive at the right model. Then you actually register the model. And the idea of registration is that you want that model to be reusable throughout your enterprise. So there is a notion of a model registry where you push your model out once you as a data scientist are happy with the model that you've come up with. And then the model registration is kind of a central repository of all the models. So if you are looking for a model for anomaly detection, for example, you can look into this model registry and get that model and sort of deploy it. Once you have a model registry, you want to take out the best model from the model registry and then deploy it, and then of course monitor the models. And all of this is sort of a cyclical process. So none of this is a linear process. It's completely non-linear. So once you build a model, you want to retrain it, you want to come back to it as sort of data is drifting. So again, this is all a very complex machine learning lifecycle that you're trying to build. So how many have heard of MLflow in this room? Yeah, awesome. So MLflow was introduced last year in June 2018, and since then it has basically just taken off. It has around 140 contributors, 800,000 I think downloads per month, and where Spark was in 3 years. So it took Spark 3 years to get to where MLflow is just within 1 year. So it's an open source machine learning framework, and we'll talk more about MLflow in the subsequent slides. But basically what we've done is we have combined the best of Azure Databricks and Azure ML with MLflow as the glue to be able to do experimentation. So you're able to log experiments into an AML workspace. You can do audit trails. So as you're building your models and deploying the models, there is a full end-to-end audit trail that's maintained. And Mike is going to show you a really cool demo shortly, which will sort of illustrate all these features clearly, and hopefully you'll get a much better understanding of what I'm talking about. Finally, when you build a model, you want to deploy them using Azure ML, and Azure ML has great model management and model deployment capabilities. So you can deploy it to the cloud, or the edge. So you might want to run your model at the edge for sort of offline processing and for predictive maintenance type scenarios. And finally, the whole machine learning operations lifecycle, which we'll talk about in detail, is also facilitated by this particular integration. So let's go through the next few slides on what is really MLflow. So MLflow, as I mentioned, is an open source machine learning lifecycle management framework. Excuse me. It has 140 contributors and almost 800K downloads per month. So it's got tremendous popularity. And what we really wanted to do is combine the strengths of open source and Azure ML with the MLflow integration. So it has basically three components. One is tracking. So I mentioned experimentation, rapid experimentation. So you can do experimentation using MLflow. So you can log the experiments in a central place. The second thing is projects. So for example, today, if you build a machine learning model, let's say a scikit model or maybe a deep learning model, and if you hand it off to somebody else, so as a data scientist, you're handing off to the machine learning engineer, there's a lot of background that you need to give in terms of what framework to install, what library to install before the machine learning engineer is able to do anything with it. So what projects offer you is a way to encapsulate all that complexity in a proper format, in a YAML file, such that you can execute the projects without really knowing the underlying details of how the model was built. And finally, MLflow Models is a common format by which you can deploy models to several downstream systems, like Azure Machine Learning is one of them. You can also use SageMaker to deploy, and so on. So it's a common model format, and as long as the tools understand the format, they can be used for deployment. So quickly, if you look at MLflow Tracking, it's basically no matter where you are, you might be on a desktop, you might be in the cloud, you might be in an app, you can use the MLflow APIs to actually log your experiments in a central sort of model tracking server, and then you can have to see your runs, or you can use the API to get that information. So it's a really nice, easy way for you to log experiments, very, very sort of low barrier to entry, to start sort of figuring out how to build reproducible models through MLflow. I talked a bit about projects, but basically the idea is there's a YAML file that encapsulates sort of the code configuration and data, and then you can execute this project either locally on a sort of laptop or remotely on a Azure Databricks cluster. So both options are supported. And finally, MLflow Models, which is the model format that I mentioned. So it has a way of encapsulating models of different types so that you can deploy it using any tool, like Azure Machine Learning is the one that we're going to show today. And this common model format allows any tools to sort of interoperate with MLflow once they support this particular format. So it's a very generic, very sort of common way for you to be able to deploy models, to the model deployment of your choice. So if you look at ML lifecycle on Azure Databricks, you do data preparation using something like Databricks Delta, and there are a lot of sessions on Delta also in the at Ignite, so you might have attended one of them. And then you build the model, you track experiments, you reproduce experiments, and you use Azure Databricks to sort of train the model, and then finally use MLflow to deploy the model. And all of this is using the Azure Machine Learning integration, which Mike will show you shortly. All this is sort of well and good. I can train my models, I can deploy my models. I sort of know how this pipeline works, but there's really more to the ML lifecycle than what we've just sort of told you. So if you look at traditional building models and deploying them, there's a data scientist that sort of trains the model. Once they're happy with the model, they just deploy it. So there is no sort of operations management or MLOps in the process. So the model just goes from your desktop to production, and then good luck, whether it really works or not, whether it's better than the previous model. And what Azure Machine Learning does is that it has an MLOps pipeline, which is the strength of Azure Machine Learning, where you're collaborating using code in GitHub, and then for training you're logging your experiments in Azure Machine Learning. Once you log your experiments, you can then push the models to a model registry. You can sort of validate your models to make sure that before you promote a model to production, is this model that you've generated really something that works? So you compare the models to production, and then able to figure out that whether the model that I've built is really something that's that I can really push to production. Once you push to production, then the whole model monitoring comes into the picture that, is the model that I have in production, is it really a good model? Is it a sustainable model? Is it behaving well with data drifting? And if not, what can I do? So there's a retraining loop, and all of this has to be audited, all of this has to be managed, all of this has to be performant. So Mike will get into a demo.
Yeah, thanks, man. Thanks for powering through that. I know your voice is all over the place today. Yeah, guys, so I'm going to show you guys some of the new stuff that we've done to bridge the gap between Azure Databricks and Azure ML. So a lot of people love to come and build their stuff in Databricks, right? They love to come and do their data science and ML in Databricks. They also love some of the model tracking and repository and deployment capabilities of Azure ML. And the third thing they like is the open sourceness of MLflow. So as Pramal kind of said, I mean, it's MLflow is just exploding in popularity, right? So the goal here was to bridge the integration between Azure Databricks and Azure ML using the MLflow open source API. So what I'm going to show you guys today is how we can use MLflow to do experiment tracking between Azure Databricks and Azure ML. It's brand new feature. It's there today, but it wasn't several weeks ago, so it's there and working. And then also how we can take the models that we build and track with MLflow in Azure ML and deploy them both as a batch or a streaming model and or as a web service, right? So first, let's talk about some basic setup, right? So for us to do this, we need to be able to link Azure Databricks with Azure ML, okay? So we've now created inside of Azure Databricks a very simple way to do this. So when you create a Databricks workspace and you browse to that workspace, we actually have a brand new button, okay? So you can come in here and you can click this Link Azure ML button. And when you click that button, it's going to bring up a page. You're going to go in here and you're going to select the Azure ML workspace that you want to link to. And when you do that, now you have this link between the two services. And that link between the two services allows for token-based authentication and things that when I'm using stuff in Databricks, it just passes over to Azure ML very, very seamlessly, okay? So that's the first bit of integration that we've done. The next thing that we need to do is we need to tell MLflow to log its stuff to Azure ML, okay? So by default, we have a managed MLflow service inside of Databricks, right? So you have to tell that service, hey, don't log to Databricks, let's log to Azure ML, okay? So to do that, very soon we're gonna have a very, very seamless integration by the end of the year, but to do that today, we run a simple init script, and I know it looks like a lot, but it's actually very simple. All we're doing is saying, hey, what's the Azure ML tracking URI that we want to set, okay? And this script will run on every cluster, okay? So now when I spin up a cluster, this script runs, and now anytime I reference the MLflow APIs, it's gonna automatically log to Azure ML, okay? So now we've got the Azure ML script set up, right? So we've linked Databricks to Azure ML, we've linked MLflow, everything is ready to go. So let's start using it. So we have a very basic case here, okay? We've got some very basic training data, some IoT data. We've already done some processing. We've put the data out into some sort of storage like a Delta Lake or some sort of feature store, right? This data is super simple, so we're not gonna teach you guys how to be data scientists today. We're just gonna show you a very simple example. We have 5 sensors. We're gonna use 4 of them to predict the 5th one, okay? Very simple stuff here. So let's talk about how we're going to use MLflow here. So we're going to build our model inside of Azure Databricks, and as we iterate over the model, we're going to log things like our metrics, log our models, log our parameters, log those things, and when we log them using the open source APIs of MLflow, they're just going to show up in Azure ML, okay? So first thing we're going to do is we're going to set the MLflow experiment, okay? So you'll note here I'm not using anything Azure ML. I'm using common open source MLflow APIs. I'm saying, hey, MLflow, let's set the experiment name. That's going to do 2 things. It's going to create the experiment out here in Azure Databricks, okay? But that experiment, all of the backend for it is actually being stored inside of Azure ML. So if I flip over to the Azure Machine Learning Studio, and I come out here to experiments, what actually gets created there is that Ignite Demo 01. Okay, so when I set that experiment, it created it, and now it's there. As we keep chugging here, now let's actually use that experiment a little bit. So the first model we're going to create and train is a simple Spark model. So we're going to use MLlib, and we're going to do a very simple random forest regressor. You don't have to understand what all this code is doing. Just know that we're using a random forest regressor to take those first 4 sensors, predict the 5th. Okay? When we do this, we want to log some stuff. We want to log what we did during this training run. So we're going to start this MLflow run, and as we go, we're going to create a model. We're also going to grab the mean squared error. We're going to grab the R squared, and then down here you see we're saying, hey MLflow, we want to log a metric. We want to log the mean squared error. Hey MLflow, we want to log a metric. We want to log the R squared. And then hey MLflow, we want to log this entire Spark model, and we want to log it to Azure ML using MLflow. Okay? So that runs. I didn't run this stuff live because some of these models take a little bit to run, and I didn't want this thing to spin for 40 seconds. Just for showing as well, we're also going to do the same thing for a scikit-learn model. Okay? Same exact process. I'm going to grab a random forest regressor here. I'm actually going to run this one 3 times for 3 different max depths of the forest. But same process. Down here at the bottom you see, I'm going to log metrics. I'm going to log the mean squared error. I'm going to log the R squared, and I'm going to log the actual model. So what did this produce? Okay? So now if we flip over here to the Azure Machine Learning Studio, and we go to the experiments page, which is where we are, and we click into our experiment, you see that all of the stuff that we just did in Databricks and that we logged with MLflow's open source APIs shows up here now in Azure ML. So the Azure ML Studio, which people really like, the charts, the graphs, the ability to go and dig into runs, find the best model, those things, they're all there, they're all available, and you can now click through. So what kind of stuff got logged? You can see the actual metrics that got logged here for each run. If we click into one of these runs, like run number 3 here, you can see all the different properties that got logged. You can see the MLflow tags. So I didn't log any additional tag. These are the standard tags that came over. But if we had logged any additional MLflow tags, like MLflow allows you to log all kinds of key value stuff, right? And so all that stuff that we logged, it just comes right over. You see the metrics, they got logged. If we come over here to the outputs, this is where the actual model got logged. Okay, so Primal talked a minute ago about the fact that MLflow has a model object that can be called and utilized anywhere, and that model object is what's actually getting logged here. So if we open this folder here, you'll see that this sklearn model logged a conda file, it logged the actual MLflow model file, and it logged a pickled version of the sklearn model. Okay, so now I'm going to want to take that model and put it somewhere, right? So now I've run through several several iterations. I've gone and done whatever my process is to identify the best model. So I've looked at the mean squared error. I've looked at the R squared. I found the model that I now want to put in production. Okay, so that model object that you just saw in the run, we want to take it and put it somewhere to productionalize, right? So let's go through that process a little bit. We're going to show you here how we can take the model objects out of Azure ML, and we're going to do 2 different scenarios. One, we're going to put that model object out there so that we can use batch and stream scoring. So I want to score a bunch of results every hour, every day, or I've got millions of records streaming in every second, and I want to do predictions on those records as they come across. The second scenario is a request-response web service. So I've got some application out there, and as people interact with the application, I want to do some sort of live request-response prediction, right? So how do we actually go about deploying these models? So you already saw that the model is sitting in a run inside of Azure ML, right? We're going to take this model, and we're going to pull it out of Azure ML, in this case, and we're going to put it out on some sort of object store. In this case, we're going to use Azure Data Lake Store. Could be a blob store. Could be some sort of object store, right? And we're going to put it out there. And once it's out there, anything that can read MLflow can now use it. All right, so that object is out there. You see that I've got it out there as a scikit-learn flavor. We don't really care what the flavor is, okay? I mean, there's scikit-learn flavors, TensorFlow flavors, Keras flavors, Spark ML flavors, okay? This could have been the Spark model that we put out here, but at the end of the day, when we productionalize this model, it's an MLflow thing. And now we can read it and use it regardless of what flavor it is, right? So this is a really great story, and I spend a little time here because I think it's very important that like your data engineers who don't know what the data scientists have built, he doesn't have to know. He doesn't have to know if this is a scikit-learn thing. He doesn't have to know if this is a TensorFlow thing. He just knows that, hey, the data scientist says, hey, I've got this MLflow model thing. I've put it out here. I need you to call it and do something with it, right? And now he knows how to grab that and work with it. He doesn't care what the underlying Python libraries or packages that were used, right? So how do we do that? Some very simple code here. The first block of this code goes out to Azure ML and says, hey, I need to grab the path to the run where the model is located. Okay, so in this case, we grabbed run number 2, which happens to be one of the scikit-learn flavors. And this just builds a path, okay, to the output folder that I showed you a few minutes ago. And then the second part of this code says, hey, MLflow, I want to grab this sklearn flavor and I want to load it, okay? And so it's going to go out there and grab it. And then hey sklearn, or hey MLflow, take this sklearn flavor of the model and put it somewhere, okay? In this case, we put it out to a TBFS location inside of Databricks that's actually a mount point to an ADLS Gen 2 storage place, okay? So now that the MLflow model is out there, and you know, Azure Functions could use it, Azure Databricks could use it, anything that can talk Python and read in MLflow can now use it, right? So one of those scenarios is, let's do batch scoring, okay? So now we've got the MLflow model out there. It's sitting on the lake, right? So let's use it. First thing we're going to do is going to read some data from Delta Lake, okay? So we're going to load up the data with Spark. The second thing we're going to do is we're going to bring the model in to Spark, and then we're going to say, hey, Spark, make a prediction using this function, using the MLflow model that we actually created, right? So if we scroll down, very simple code here, guys. Like it's just a couple of lines of code to do this. So the first thing we do is bring in the actual model. So hey MLflow, I need you to create a pandas UDF, a Spark function, a Spark UDF from the model that's out here in this location. Okay, that's the first thing it did. So now I've got a function that I can use to tack on as a column to any Spark data frame. Okay, second column there just loads up a data frame with some data, so scoredf, spark.table.sensor, so we're going to read in some sensor data, this time where the device ID is 100, right? And then this last code makes this last block of code actually makes the prediction, right? So scoredf, let's add a column, let's call it sensor5 prediction, and use the Python function that was made from the MLflow model and pass it these 4 columns. Okay, so the 4 columns that we want to use, sensor 1 through 4, pass those in, and then give me a new column called sensor5 prediction, and there you go, right? So the output of that is now we've got this column on the end that are the actual predictions, and this can now be implemented in any kind of ETL pipeline, right? So this is, if you're doing a batch ETL pipeline, if you have structured streaming and you're streaming tons of events per second, this prediction can be made on the fly live in fractions of a second. The final use case that we'll talk about is taking that same model that we put out there on the lake and pushing it out to some sort of web service, okay? So this has been around for a while, so Azure ML has been doing this for at least the last year, I believe. And so we're going to take that model, we're going to use MLflow, and we're going to say, hey, MLflow, let's put the model into Azure Machine Learning and have Azure Machine Learning put it out there as a web service where the Docker container is stored in container instances. Couple lines of code here. The first block of code here says, hey, MLflow, I want you to build this Azure ML image. I want you to go out to the location in the data lake where I put this model and grab it and use that to build the image, okay? This you can see takes 6 minutes. You definitely wouldn't have wanted to see this live. The second process, now we are using a little bit of Azure ML code at this point. So we've broken from MLflow here. So everything you've seen so far, we haven't written really a single bit of Azure ML code. This has all been MLflow code up to this point. Now we're going to use a little bit of the Azure ML SDK, and we're going to say, hey, hey Azure ML, I've got this image out here. I need you to create a web service for me. Okay, and when you do that, what happens is Azure Machine Learning now creates this endpoint, and here's the endpoint we created this morning. And now the model that was built in Databricks, deployed with MLflow, is now out there as a web service. So not that you would usually call a web service from Databricks. You would usually call it from an application, but we just want to show you the functionality here. So we grab some sample data, right? We grab the model URI, which is the web service endpoint that I just showed you here. And we create a very basic function that says, hey, call this web service endpoint, pass it this data, and you see within a couple of tenths of a second, it returned a prediction. Okay? So that's kind of it from a demo perspective. So we showed you here, some of the newer capabilities around being able to link Azure Databricks with ML or with Azure ML using open source MLflow APIs, right? So you're able to use open source libraries and log directly to the very popular Azure ML repository and model deployment services, right? A couple of quick things about some roadmap. So what you saw here today, you can do. So as soon as you leave, all that is functional. We've got some instructions and stuff on how to do that and some links on where to do that. The integration is going to be even tighter by the end of this year, first of next year. You're actually going to see where I showed you in a knit script. You're probably not going to need that anymore. It's probably going to be a button. You're probably going to have some very simple drop-down-y tools to be able to do that. And that better together story tight integration is going to continue to evolve and hopefully make things easier for you guys. That's it, guys. That's all I got.
We wanted to leave 10 minutes for Q&A, so any questions or comments, or feel free to come to the mic and ask.
We do have a couple of booths as well out there, so we're manning the Azure Databricks booths, and the ML guys are right next to us as well. So. Yeah. Sorry, are you able to step to the mic? Sorry, I can't hear you at all. For data lake, so you can push those models out to any object store. So MLflow reads from, off the top of my head, I believe it reads from a DLS, from a BFS, and from Blob.
Yeah, both are supported.
Yeah. Yep.
Yeah, come on, Mike.
Some documentation around like a general optimization workflow once the models are created, like if you're like planning to optimize it, like is there some documentation around that?
Are you referring to sort of MLOps?
Not ops, just like model optimization.
I see. So like how do you come up with the most optimal model?
Yeah. So it's like you have an objective function and then things like that. So we're trying to like work our way through automating that workflow. So we have, right now at our current state, we have a model creation done, but we're trying to automate model optimization also. So is there like something that you guys?
So both Azure Machine Learning and Databricks have some AutoML and HyperOp type functionalities and features. I think it's you'd want to talk to both groups. So we've actually got, at the Databricks booth, we've got a data scientist there that can talk to you a lot about the hyperopt and kind of auto ML features within Databricks. I know that the Azure ML guys can also talk to you a lot about some.
So are you talking about like automated machine learning type? Yeah. So as Mike said, like if you want to do automated machine learning in Azure Databricks, you can either use the Azure machine learning libraries, or you can use a combination of what they offer and hyperopt that we have integrated. So there's like a bunch of options that you have to sort of automate.
Hello. For real-time analysis or near real-time analysis in the IoT purposes, how can you do that?
So exactly what I showed you today. Yeah, so exactly what I showed you today, where I did a spark.read.sensor, okay? There's no reason that could not have been a spark.read stream from Event Hub, and the process would have been 100% identical. That's one of the fantastic things about Spark, right, is whether you're doing batch or you're doing stream, okay, you're able to create the exact same code. And the same process that I showed you where we made the prediction from a batch standpoint works for streaming. So it's pretty cool.
Streaming up until the graphical user interface. Well, obviously with other bricks. So it streams. There's no stop at all. Everything is streaming in your steps. Is that right?
Yeah. So when you're
slow point.
When you're using structured streaming, I mean, it is a constant stream, but it's the subsequent steps after that allow you to, like, if you need to maintain state and do stateful streaming and write out partial results into additional type analysis, there's plenty of ways to do that. But generally speaking, the batch or stream scenario shouldn't matter too much in Databricks. The code is very, very similar.
Thank you.
Yep.
First, it's like I'm very new to Azure Databricks. So, but we have used Azure ML a lot. So it looks like MLflow and a lot of stuff like that you guys showed can be done in Azure ML using MLOps and other stuff. So as a developer, like, what is the advantage of, like, trying to take some of this stuff and then do it in Databricks and then bring it back to Azure ML? I understand, like, Azure Databricks doesn't have that, like, graphical user interface of, like, giving metrics about, like, the model, explanation about the model, or, like, other accuracy metrics and things like that. So but still I'm not able to, like, understand.
So it does. So one thing I didn't show you was the MLflow UI. All right. So there's definitely a lot of Azure machine. There's a lot of overlap between Azure ML and MLflow. I think, what does Databricks bring to the equation? So Databricks, being a distributed Spark engine, right, allows you to take single-threaded things that you would be doing locally, like single-threaded Python functions, right? And now we can distribute them. Whether that means I have a much larger data set that I need to run against and I need it to distribute it, or whether or not, or it may mean I have 100 different IoT devices and I need to train the same scikit-learn model on all 100 of those, and I don't want it to run in some loop that just runs it sequentially over hours and hours and hours. I want it to run all of them at the same time, and what used to take 2 days now takes 2 hours, okay? So those two scenarios, Databricks is fantastic for, right? As soon as you've met the peak of what you can do locally, then bringing it to Databricks for that distributed processing is great.
Also, I wanted to add to what Mike said is that if you want to do large-scale machine learning, so you have large amount of data and you want to build a large machine learning model, you can use like Spark's MLlib, which what Mike showed you on Azure Databricks, and then use Azure Machine Learning's deployment capabilities and also experimentation capabilities. That's what the demo showed you. So you can, no matter where you start from, we've tried to integrate such that for a user or a customer, it's an end-to-end complete experience.
Okay, so sorry, the second question. So I don't know if this is the right session, but also, like, we're talking about, like, two different lakes, right? So one is like the data lake from Azure and your data lake. What is the major difference between the two lakes?
So, and we can definitely, I'd encourage you to drop by the Databricks booth. We've got a great couple of demos about Delta Lake and can talk to you about it. The 1-minute elevator pitch. Delta Lake is a storage format that is highly optimized that works in your data lake. So if you're using blob storage or you're using Azure Data Lake Store, okay, you would store your Delta Lake files, the files that are in that format, in those object stores, right? And the format, it's a highly optimized Parquet format that also has a transaction log that sits with it, so that we can do transactions on that data. We can do upserts. We can do inserts, updates, deletes on that data. We can look at what the data looked like 3 weeks ago if we want to. Okay, so there's a lot of features that storage format that have kind of brought together some of the traditional flat file storage with some of the capabilities of maybe some sort of a data warehouse, and made it a little more optimized for that. So it's just a storage format, so don't get too bogged down. Like, it's not two different systems, it's a storage format. But we've got a lot of content out there at the booths that we can definitely share with you.
Thanks, guys. Thank you so much.
Thank you.
Yeah.
Could you please shed some light on the end-to-end pipeline? So this pipeline talked about data science specific. If the preparation is done by a data engineer and data scientists coming in the mix, release management coming in the mix, how would that CI/CD pipeline, end-to-end CI/CD pipeline would look like, including Databricks and MLflow?
Sure. You want me to tackle that?
Yeah, so maybe you can just talk here, I guess.
Any other?
Yeah.
All right, cool. Thanks, guys.